Hi everyone, welcome to My Max Academy. In this video, we'll continue with the chapter Coordinate Geometry, which is chapter number 7 from your 10th standard CBSE Mathematics. In this video, we shall continue with exercise 7.4 in page number 171 in your textbook, problem number 1. So what problem number states is, determine the ratio in which the line 2x plus y minus 4 equal to 0 divides the line segment joining the point A of 2, minus 2 and B of 3, 7. So what it means is, we have a line, suppose we have a line, since the line segment, suppose there is a line which is, this line is 2x plus y minus 4 equal to 0, and there are say two other points. Say suppose this is 2 minus 2, which is point A, and then another point, suppose this is B, which is 3 7. Now we need to find the ratio in which this line 2x plus y minus 4 divides the line segment joining the points A and B. Divides the line segment joining the points A and B, which means if this is the point at which this line 2x plus y minus 4 divides the line segment joining these 2 points, we need to find at what ratio it divides, which means we need to find, suppose if this point is C, suppose we need to find what is the ratio, this is to this, we need to find this ratio, AC is to CB, we have to find the ratio AC is to CB. We have to find the ratio in which this line divides the line segment joining these 2 points. Suppose if this line 2x plus y minus 4 cuts the line at the point C, now we need to find the ratio of AC is to CB. So we'll assume that ratio is, suppose K is to 1. The ratio is K is to 1. We need to find the value of K. Now we'll say the solution. Right? We'll say let C be the point. C be the point of intersection of line 2x plus y minus 4 equal to 0 and AB and the line segment AB. Right? This line and the line segment, they intersect the point C, and we'll say let C divides AB in the ratio K is to 1. Now we need to find the value of K. We need to find the value of K. So now C divides the line segment AB in the ratio K is to 1. Then we can apply the section formula. What section formula says? By section formula, what we have is, we can write the point C as K x2 plus x1 by K plus 1, K y2 plus y1 by K plus 1. So this is what the section formula says if C divides the line segment AB in the ratio K is to 1, where this is your x1 y1, this is your x2 y2. Now we shall substitute these values here. So C of K into x2 is 3 plus x1 is 2 by K plus 1, K into y2 is 7 plus y1 is minus 2 by K plus 1, right? So x1 y1, so x2 is 3 plus x1 is 2, K plus 1 plus K into y2 is 7 plus y1 is minus 2 by K plus 1, close. So this is our point C. Now if you simplify this becomes 3k plus 2 by K plus 1, 7k minus 2 by K plus 1. But this point C, it lies on the line, it lies on the given line. So which means this point must satisfy this equation of the line. So C lies on the line, which line? 2x plus y minus 4 equal to 0. Therefore, C must satisfy the equation, this one, 2x, it must satisfy the line equation, 2x plus y minus 4 equal to 0. Now, if you substitute C in this equation, in the place of x, we are going to put this, the place of y, we are going to put this. So, if you substitute the point C in this, so we have 2 into x. X's will substitute 3k plus 2. So, 2 into 3k plus 2 by k plus 1 plus y into plus y. So, y is, we have to substitute the value of y plus y is the 7k minus 2, 7k minus 2 by k plus 1. So 2x plus y minus 4. So minus 4 equal to 0. So we are substituting this x and this as y in this equation because the point C lies on this line. So any point that is on this line, that will satisfy this equation of the line. It must satisfy this equation. So now if you simplify this, what do we get? 2 into 3k, 6k plus 4 by k plus 1 plus 7k minus 2 by k plus 1 minus 4 equal to 0. Now k plus 1 is there in the denominator. If you multiply throughout by k plus 1, then we will get 6k plus 4 by k plus 1 into k plus 1 plus 7k minus 2 by k plus 1 into k plus 1 minus 4 into k plus 1 equal to 0 into k plus 1. So we are multiplying throughout by k plus 1 so that this denominator can be eliminated. So here k plus 1 gets cancelled, k plus 1 gets cancelled. So we get 6k plus 4 plus this is 7k minus 2 minus 4 into k minus 4k minus 4 equal to 0 into k plus 1 is 0. Now if you simplify this, 13 minus 4 is 9k, 4 and 4 are gone, minus 2 equal to 0. So you get k is equal to 9k is equal to 2. So k is equal to 2 by 9. So we have found the value k as 2 by 9. Therefore the ratio in which these devices, therefore the ratio is 2 is to 9. So when you get k as 2 by 9, the ratio is 2 is to 9. Because in our section formula where we had used, the k was m1 by m2. K is actually what? M1 by M2. If you take this as M1 and this as M2, then the value of K is M1 by M2. If the ratio is M1 is to M2. If you take the ratio as K is to 1, then value of K is M1 by M2. So the ratio is 2 is to 9. So this is the ratio in which this line 2x plus y minus 4 equal to 0 divides the line segment joining these 2 points. Fine. So this is the answer. The ratio is 2 is to 9. So all of you can pause the video and take the notes. I'll go to the next question. Okay, so second question is question number 2. It says find the relation between x and y if the points x comma y, 1 comma 2 and 7 comma 0 are collinear. So what is given is there are 3 points. Suppose this is A of x comma y and B of 1 comma 2. This is 7 comma 0, which is C. The point, this is, I'm just taking it as C. Now these 3 points are collinear, which means they lie on the same line. They lie on the same line. Now we have to find what is the relationship between x and y, or what is the relation between x and y. If they say what is the relation between x and y, means we need to find an equation having x and y. We need to find an equation having x and y, that will be the answer. Now since these 3 points are collinear, they have given that they are collinear. So what is given is A, B and C are collinear, and what we should find or to prove or to find is relation between x and y. And find the relation between x and y, right? So what it is? So solution is, now since the points are collinear, then we know that the area of the triangle is 0. The points are collinear, area of the triangle ABC is 0. So we'll say area of triangle ABC, because the triangle cannot be formed because they are collinear, is what? 0, because ABC are collinear. Now what is the area of the triangle ABC formula? That is half of x1 into y2 minus y1 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is the formula to find the area of the triangle when three vertices of the triangle are given. Here ABC is not a triangle. That's why we are putting the area as 0, because they are collinear. So we'll put this equal to 0, because area of the triangle is equal to 0 and area of the triangle formula is this, that is equal to 0 because the points are collinear. Now we'll substitute these. So we'll take this as x1 y1, x2 y2, x3 y3. If we substitute all of this here, we get 1 by 2 of x1. x1 is x. x1 is x into y2. y2 is 2 minus y3 is 0 plus x2. x2 is 1 into y3. y3, this is y3, which is 0 minus y1. y1 is y plus x3. x3 is 7 into y1. y1 is y minus y2 is 2 equal to 0. And we have to close this bracket. Now what do we get? We get 1 by 2 of x into 2 is 2x minus y. This is plus 7 into y is 7y minus 7 2s are 14 equal to 0. Now this 2 will go this side. So this 2 will go to the other side. So you get here 2x plus 6y minus 14 equal to 0 into 2. Because this 2 goes to the other side, it becomes 0 into 2. Now if you simplify this, we get 2x plus 6y minus 14 equal to 0. Now we can cancel throughout by 2. We can divide throughout by 2. You get x plus 3y minus 7 equal to 0. And this is the required relation. This is the required relation between x and y. This is the required relation between x and y. Fine. So all of you can pause the video and take the note. This is actually basically, this can also be asked as, this is the equation of the line AB. They say, what is the equation of the line AB? This is the equation of the line AB. Anyway, so we wanted to find a relationship between x and y, and this is the relation, x plus 3y minus 7 equal to 0. Whenever x and y satisfy this condition, then the 3 points will be collinear. Right? So all of you can pause the video and take the notes. Right? So I will go to the next problem. I'm erasing this. So third question. Third question is, you have to find the center of the circle. Find the center of the circle passing through the points 6, minus 6, 3, minus 7, 3, 3. So there is a circle. And we have to find the center of the circle. Suppose the center O. And this circle is passing through the point 6, 6. Suppose let's take 3 points. This is 1 point, 2 point, and 3 points. Suppose this is A of 6, minus 6. And say this is B of 3, minus 7. And this is C of 3, 3. So these are the 3 points through which the circle is passing through. We need to find the center of the circle. Suppose we don't know the center of the circle, we'll take this center of the circle as suppose H, K. What is the center of the circle? H, K. We have to find H and K. We have to find H and K. So we'll say solution is, the circle is passing through these points A, B and C, and we need to find the center of the circle. We'll say let O of H, K be the center of the circle. Center of the circle. Fine. Be the center of the circle. Now what we have, since this is the center and A, B, C lie on the circle, therefore we have OA is equal to OB is equal to OC, because all are radius. OA, OB, OC all will be same because they are radius of the circle, radius of the circle. So now we'll have to form the equation to find the value of h and k. Now we'll first take these two. OA is equal to OB. We'll take OA is equal to OB. Now we'll try to apply the distance formula between these two. When OA is equal to OB, right, we can even say our OA square equal to OB square. OA square equal to OB square. Right. So what is the distance formula? Distance formula is, so our OA square will be distance between these two. That will be equal to, we can apply our distance formula. That is, if you take this as x1 y1, this as x2 y2, then we will apply distance formula. Distance formula says square root of, but we will not say square root of because we are finding OA square, so there won't be any square root, right? So we'll have, so your OA square will be x2 minus x1 the whole square, which means 6 x2 minus x1, 6 minus h the whole square, plus y2 minus y1 minus 6 minus k the whole square. What is our distance formula? Distance formula is, distance is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. If you find the distance square, then it will be x2 minus x1 the whole square plus y2 minus y1 the whole square. If I don't put the square root, then I have to put the square here. Basically we are squaring both sides, so that's why I'm not putting the square root, because we are writing OA square. OA square is x2 minus x1 the whole square plus y2 minus y1 the whole square equal to OB. Similarly, if you take OB, if you take this is x1 y1 and if you take this x2 y2, then again x2 minus x1 the whole square, which is 3 minus h the whole square plus minus 7 minus k the whole square. 3 minus h the whole square plus minus k minus h the whole square. Now if you expand this, right, if you expand this, this is a square, which is 36 square, a square minus 2ab, 2 into 6 into h. Right, if you want, I can write one more step. So a square, so 6 square minus 2ab, so 2 into 6 into h plus b square is h square plus, again it is minus 6 minus k the whole square. So we have to be careful in applying the a plus b the whole square or a minus b the whole square, which we will apply a minus b the whole square. So this is your a and only k is your b. So a minus b the whole square is a square minus 2 into a into b, b is k plus p square. So your b is only k, your a is minus 6, and this minus is the formula minus. A minus b the whole square is a square minus 2ab plus b square. For a you have to put minus 6, but b is only k, don't put minus k. That is equal to, up again apply a minus b the whole square, that is a square minus 2 into 3 into h plus b square, which is h square, then again plus, here also we can take this as a, so minus 7 the whole square, so what I will write it here, plus minus 7 the whole square plus 2 into minus a minus b the whole square, a square minus 2ab into plus b square plus b square. So a is minus 7, b is only k, b is not minus k, a square minus 2ab plus b square. Now if you simplify this, you get 36 minus 12h plus h square plus this is 36 minus 1 minus plus 12k plus 12k plus k square equal to 3 square is 9 minus 6h plus h square. This becomes plus 49 plus 14k plus k square. Now if you see this, anything is getting cancelled. We will see that h square here and h square here gets cancelled. K square here gets cancelled. So I'll bring all the h and k to one side and number to the other side. So I will keep the numbers here. 12h plus 12k equal 12h plus 12k. Then this minus 6h will become plus 6h. It comes this side. 14k comes here. It will become minus 14k equal to 36 plus 36 is 72. That goes to the other side. So here 9 plus 49 is 58. 58 minus 72. Whether it's 36 plus 36 is 72. 72 goes that side, minus 72. 9 plus 49 is 58. So that gives you minus 14. And this gives you 12. H plus 6h is minus 6h. 12k minus 14k is minus 2k equal to minus 14. right? So if you cancel throughout by minus 2, cancel throughout by minus 2, right? If you cancel throughout by minus 2, what do we get? So we get minus 6h by minus 2 minus 2k by minus 2 equal to minus 14 by minus 2. I'm dividing throughout by minus 2. Then what do we get? We get 3h plus k equal to 7. Call this as first equation. 3h plus k equal to 7. Call that as the first equation. Now we'll equate maybe OB and OC or OA and OC, any one of them. Right? So we'll probably equate OB and OC. So OB is equal to OC. Therefore, OB square is equal to OC square. OB square is equal to OC. Let's find what is OB. Now OB we already found here. This is this one, right? Right. So if you apply OB square will be x2 minus x1. That is 3 minus h the whole square plus minus 7 minus k the whole square is equal to OC square. OC square is, if you take this as x1 y1 and this as x2 y2, and again x2 minus x1. So 3 minus h, x2 minus x1 the whole square. So we are using this formula plus y2 minus y1. y2 is 3, y1 is k. So 3 minus k the whole square. Now if you expand this, now or we can even, if you observe this, these two will get cancelled. This is 3 minus h the whole square, this is 3, this is also 3 minus h the whole square. These two gets cancelled. Right? 3 minus h the whole square. This is also 3 minus h the whole square. So those two gets cancelled. Now what do we get? If you expand this gives you a square minus 2 into a into b plus b square equal to again a square. 3 square minus 2 into a is 3 into b is k plus b square. Now again k square gets cancelled. So you get 7 square is 49 minus into minus plus 14k equal to 9 minus 6k. 6 will come here, you will get 20k equal to 40 goes to the other side, 9 minus 49. 9 minus 49. Minus 6k comes here, it will become plus k. 6k, if I want to write one more step, 14k plus 6k equal to 9 minus 49. So you get 20k equal to minus 40. So k becomes minus 40 by 20, which means k is 2, minus 2. K is minus 2. Now we got k. Now let's substitute k as minus 2 here in the first equation. So substituting k is equal to minus 2 in 1. See, our aim is to find the value of h comma k. Right? So 3 into h plus k is minus 2. So minus 2 equal to 7. So you get 3h minus 2 equal to 7. So 3h is equal to 7 plus 2. So 3h is equal to 9. H is equal to 9 by 3. H is equal to 3. So we have found k and we have found h. So the center is what? H comma k. H is 3, k is minus 2. So 3 comma minus 2 is the center of the circle. Therefore the center of the circle is what? H comma k. H is 3, comma k is minus 2. 3 comma minus 2 is the center of the circle. So that's answer. Fine. So all of you can pause the video and take the notes. I will erase this. We'll go to the next question. Next question is question number 4. So what is given is the two opposite vertices of a square are minus 1 comma 2 and 3 comma 2. Find the coordinate of other two vertices. Find the coordinate of other two vertices. Fine. Okay. So the two opposite vertices. So let's draw the square. So fourth question is, let me draw a square. This is a square. So this is A, B, C and D. So two opposite vertices are given, which means we'll take this as minus 1 comma 2 and this is 3 comma 2. Now we have to find the coordinates of the other two vertices. We have to find what is B, what is D. We have to find what is B, what is D. So we'll first take this B as x comma y. We don't know B, we are taking it as x comma y. Right? We'll calculate D also, but we'll take B. Now, so we'll say solution. We'll say let B of x comma y be another vertex of the square. Another vertex of the square. We have to find D also. We have to find B and D. Let's try to find B first. Now A and C are two opposite vertices of a square. Right? Now, since it is a square, we have AB is equal to BC because all the four sides are equal for a square. So, this side and this side are equal, which means the distance between AB and distance between BC are equal. Distance between AB and distance between BC are equal. So, which means our AB square is equal to BC square if you square both sides. We are squaring both sides so that we can find the distance without the square root. Now, let's apply the distance formula between these two. So, AB, right? If you take this as x1, y1, this as x2, y2. Now, what is the distance between these two? AB is x2 minus x1, which is actually square root of. But we will not put the square root because already we are considering the square of the distance. So, this is square of the distance. If AB is D and this is your AB square is this, where A and B are the 2 points for which we are finding the distance between. So AB square is D square, so which is without the square root. If I write AB, it is with the square root. AB square means without the square root, this formula. That is the distance formula. So AB is, again we'll write x2 minus x1, which means x2 is x minus x1. So minus of minus 1. x2 minus x1 the whole square plus y2 minus y1. y2 is y minus y1 is 2 the whole square is equal to, now BC. BC square is, we'll take again this as x1 y1 and this as x2 y2. Again we'll apply the distance formula. x2 minus x1, which means x minus 3 the whole square plus y minus 2 the whole square. x2 minus x1 the whole square plus y2 is y minus y1 is 2 the whole square. Now if you observe here, again this is y minus 2 the whole square, y minus 2 the whole square, they get cancelled. So you'll have x plus 1 the whole square is equal to x minus 3 the whole square. Then let's evaluate. So if you expand this, a square plus 2ab plus b square equal to, here if you apply a square plus 2ab, 2 into x into 3 is minus 6x plus 9. Now again x square will get cancelled. This 6x will come here. So you'll get 2x plus 6x is equal to 9 minus 1. So 8x is equal to 8. X is equal to 8 by 8, which is 1. So what is the value of x? X is 1. So we have found the x. Now we need to find y. We need to find y. Once we find y, we'll get the coordinate for b. And if you see d, if you apply the same logic, ab is equal to dc, you'll get d's coordinate also as 1. D also 1 if you take the same logic. Same thing if you apply ad square equal to dc square. We don't have to do that because the same things we are going to repeat. So let's find y now. So we have found the x for b. We'll find the y for b now. So for which we have to use another property of square. So one of the properties that we used for square is the adjacent sides are equal for square. So all sides are equal actually. So AB is equal to BC. We got this x. Now another property of square is each angle is 90 in a square. So therefore, if I join AC, we can apply Pythagoras theorem for this. We can apply the Pythagoras theorem for this, which means your AB square plus BC square is AC square. So by Pythagoras theorem, what we have the square of the hypotenuse equal to sum of the squares of the other two sides. Or we can also say AB square plus BC square is AC square. We are going to use this property to find the value of y. Now what is AB? AB is the distance between A and B. Right? We'll take this x2 minus x1 the whole square. That is x2 is this. It is x minus of minus 1 is plus 1 the whole square plus y minus y2 minus y1 the whole square. So y2 is y minus y1 is 2 the whole square. Right, here you have, if you want I can write this, x minus of minus 1 the whole square plus y2 minus y1 the whole square equal to, now sorry, plus this is your ab square plus bc square. BC is these two. So again we'll apply x2 minus x1, which means this one, x minus 3 the whole square plus y minus 2 the whole square equal to AC square. We'll take the distance between these two. We can take anyone as x1 y1, x2 y2. We can take this as x1 y1 and probably this now has x2 y2 to apply the distance between AC. So x2 minus x1, 3. So 3 minus 1 the whole square, that is x2 is 3 minus x1, x1 is minus of minus 1 whole square plus y2 minus y1, 2 minus 2 the whole square, 2 minus 2 the whole square. Fine. So now if you simplify this becomes x plus 1 the whole square plus y minus 2 the whole square equal to x minus 3 the whole square plus y minus 2 the whole square equal to, now 3, this is 3 plus 1, 3 plus 1 is 4, 4 square, this becomes 4 square, 2 minus 2 is 0, so this is 0 square, 0 square is 0, so we'll put plus 0 square. Now if you see this, now we know the value of x is what, 1, x is 1, we'll substitute x as 1 here, we know the value of x is 1, substitute x as 1 here, then what do we get, 1 plus 1 the whole square plus y minus 2 the whole square is equal to 1 minus 3 the whole square because x is 1. So in the place of x, I am substituting 1 plus y minus 2 the whole square is equal to 4 square is 16. So 1 plus 1 is 2, 2 square is 4 plus, sorry, this is plus, now this is y minus 2 the whole square, this is also y minus 2 the whole square. So we can expand this, or we can put as 2 into y minus 2 the whole square. We can write as 2 into y minus 2 the whole square. So y minus 2 the whole square plus y minus 2 the whole square is 2 y minus 2 the whole square plus 1 minus 3 the whole square is minus 2 the whole square is 4 equal to 16. Now 2 into y minus 2 the whole square equal to this, these two 4s will go to the other side. So you'll get 16 minus 4 which means 8. So that is 2 into y minus 2 the whole square equal to 8. So your y minus 2 the whole square will be equal to, if I divide 8 by 2, this 2 comes to the other side, RHS, so it becomes divide. So you get y minus 2 the whole square is equal to 8 and 2 will get cancelled, 4. Y minus 2 the whole square is 4. Now you can expand this, or we can even take this square to this side, but no, you people may not be comfortable with that. So I will expand this. So a square minus 2 into a into b plus b square is 2 square is equal to 4. So y square minus 4y plus 4 equal to 4. Now if you bring everything to one side, so y square minus 4y plus 4 and this minus plus 4 comes this side, minus 4 equal to 0. So both will get cancelled. So y square minus 4y equal to 0. So y is common, y minus 4 equal to 0, which means either y is equal to 0 or y minus 4 equal to 0, which means y is equal to 4 or y is equal to 2. Now what we have got? We have got either y is 0 or y is 4. We got y is 0 or y is 4. Now we have got x as 1. So the points will be, therefore the points are, I'll write the conclusion here probably, I'll write it here. Therefore the points are vertices are, we can say the vertices are b of x comma y, x is 1, so 1 comma y is 0, 1 comma 0 and 1 comma 4. 1 comma 0 and 1 comma 4. 1 comma x is 1, y is 0. So 1 comma 0 is one vertex, then 1 comma 4 is another vertex. So this has to be B, D. That has to be D. That has to be the other vertex. So we have found the other two vertices, which are 1, 0, that is B, and D of 1, 4, right? I'm writing that again. B of 1, 0 is one vertex, and D of 1, 4. B of 1, 0 and D of 1, 4 are the remaining two vertices of the square. Fine. So all of you can pause the video and take the notes. I will stop the session here. You can watch my next session for the continuation of this. Thank you for watching.